Always for gases.
So why do it say gas liquid? Oh, never mind. So even if it's a gas with a liquid or a gas by itself, the gas is gonna always the solubility of the gas.
Well, it's hard to have a solubility of a gas by itself.
Oh.
Okay, you're talking about the solubility of the gas going into something, so probably
Right.
into the liquid. So yes, the solubility of a gas is always greater at lower temperatures than it is at higher temperatures.
The solubility of a gas is greater.
Lower temperatures as opposed to higher temperatures. Anything else?
I have a question.
Yeah.
I was like trying to do some of the problems, and it had a lot of percent weight problems. Did we go over it?
No, that's on the agenda for today.
So, if we just going over it today, how are we gonna like master it?
You're going to spend a lot of time between now and next week to
But it's
master it.
difficult.
Well, I'm sorry. Come see me if you're having trouble. A week is certainly ample time to.
So what is
Today's
the 14th? You said the solubility of a gas decrease when the temperature increase?
Yes. Okay. So we left off talking about solutions, and we said that a very important consideration for solutions were concentrations. Now we've already talked about some terms that allude to concentration. We've talked about when a solution might be dilute, has a relatively small amount of solute. A concentrated solution would imply what? Relatively large amount of solute. So lemonade, for example, if it's extremely tart, then it means you've got a lot of lemons in there, so it's a very concentrated sample. We've also talked about unsaturated, saturated, supersaturated, and so we've used terms to describe solutions, but what we've decided is that the best way to describe a solution to someone is to use a number, some kind of quantitative description. And we are going to talk about two of them. And so the first one is called percent mass. Now, these concentration units for solutions that we described to you have very rigid mathematical definitions. And so we can define percent mass of some component, let's say A, as being the mass of A over the total mass of the solution times 100. We're looking at a fraction times 100 changes it into a percentage, and so this is how we do the calculation. So why don't we try one? Suppose I gave you some data. You have 500 grams of sodium hydroxide. The molecular mass of sodium hydroxide is 40 grams per mole, and you're putting it into 1,500 grams of water. So C, you have 12 seconds to see if you can calculate the mass percent based upon our mathematical formula.
There's the two, so like, I can divide 500 grams of NaOH by 1,500 grams of H2.
You can.
Okay.
You're allowed to.
Is that
I'm not
correct?
going to tell you yet. You do it and then we'll see. You do what you think is right in your heart.
I don't think this is like
Okay, do we get an answer?
3%.
1 second.
Anybody?
I got 3%, but I don't think
3%.
it's right.
So why would it give you
Anybody get a different answer?
the molecular weight?
76%? There's a little bit of a different answer. 25%. We keep going, we might be able to get, how many people are in this class? 59 different answers if we keep trying.
Okay, I got 25.
How much? 30%? 33.3%. So this would be a good multiple choice question with all these answers. And you have to pick the right one. I think the correct one is 25%. Good job. How do we do it? Let's go put the numbers in. All right. One of the things that people often ask, are there going to be definitions on the test? And a lot of times the answer is probably not per se. I mean, the question is probably not going to say, what is a solute? Okay? But if you don't know the definitions, you're likely to screw something up like this. Okay? So, we want to know the mass of A. Now, mass of A in this case is the solute. And that's the most common form of mass percent in a solution, is to find the mass percent of the solute. So, what is our solute? It's the NaOH. So, that's 500 grams. And that's divided by the total mass of the solution, which is 2,000 grams.
Where do you get it?
Now, most people will take 1,500 grams because it's the water, and that's why you're getting 33.3% if you use the 1,500. But remember, this is just the solvent. This says
Total.
solution. And the solution is made up of the solvent and the solute. And so this has to be 2,000 grams. Then when you multiply by 100, you get 25%. Now how you got 3, 76, or 30, I'm not really sure.
15.
How?
I thought it was 150 instead of 1,500.
That's what I thought too at first.
I think so.
150, so then do you use water as the solute?
So how did you get 2,000?
Because 500 plus 15.
Add them together. Okay.
The two together.
I used 15,000 and didn't add them.
15,000.
Yeah. And I didn't add them together, so I did 5 divided by 15,000 times 100, and that's why I
That
got
makes
3.
a difference.
What's the point in giving the molecular
Yeah, that's
mass equals 40?
What's the point of giving the molecular weight? And it's simply there to be tricky.
Okay.
Does that satisfy you? No, the reason it's there is that by this point, I'm assuming you know how to do molecular mass. And in some of these problems, as we go along today, you'll see that it's necessary. You will need the molecular mass to do the problem. So out of the kindness of the instructor's heart, he's going to give you the molecular mass. But he's going to give it to you all the time, whether you need it or not. So you have to decide, do I need the molecular mass here or do I not need the molecular mass here? And it might be that in part A of the problem you don't, in part B that you do, and so it may be there for different reasons. Okay?
What goes in the percent mass 8 again?
It's the answer. In this case, we're looking for that. So we have the mass of the solute over the mass of the solution, and we calculate the percent mass.
And the solution is the, what is the H2O? That's the solvent?
That's the solvent. So the
So the
solution is
solvent.
everything together.
Okay, the solvent plus the solid together. And then-
Yes.
Okay.
Now, I can make this be the correct answer by changing only one word here. If the problem says this, then that changes the ball game, and our total mass of the solution is 1,500, and it turns out to be a third, or 33.3%. So what's the moral here? Read carefully. Know your stuff, so that you can say, this is this, this is this, this is what I need, this is what I don't need, and that you're getting the correct answer. Because I can guarantee you, if this is a multiple choice problem, both of those answers are going to be there. And those of you that get the 33% are going to be thinking, oh, I'm bad, I'm bad. And in fact, you are bad.
Can we do another one?
Sure. Can I complicate the problem any?
Of course you can. Pretty sure you'll find a way.
Do a simple one and then complicate it?
Yes.
Okay, that's fair. Okay, go.
Did I say million?
Oh yeah, my bad.
ML.
We'll make it grams. That's even simpler.
So,
You didn't use 15,000 again, did you?
no.
Okay.
Still right in the bottom.
Who said what?
Say at the top, add 25 grams
Sugar.
sugar.
Molecular mass is 342. This is, okay,
No.
survey says
20%.
20%. You got it?
Yeah.
Anybody get 25%? Excellent.
Yeah.
Learn. All right, now we can complicate it?
Guess so. Wait.
Can we work that out?
Sure. What's the solute?
Solid is the, sugar,
And how much do you have?
25,
And what's the solution made up of?
100 grams of H2O.
Just
Oh,
water?
plus, 125 for sugar.
And that's 20%.
Mm-hmm.
Okay, go.
Oh, that's per milliliter, not liter. Okay.
What's the answer? Huh? What's the answer? I don't know, just see what works. I know you have to do, but you have to convert density equals mass. Yeah. Yeah, so, I was wondering. Yeah.
No answer? Yes. Sure.
You've given us the density. Yeah, so you have to do the, even the density over the value with the mass. Yeah.
I got 27.
How did that, did you convert it?
So I got 28.
You didn't convert
Me?
it?
I can do it.
So it is 28%?
You're right.
28, 47.7. Yeah. Okay.
Yes. No, not your mom. You're just a blue like
What did you guys do? What do you guys like?
the last one.
Answers, whatever it is.
Yeah.
And answers.
Oh my goodness. Okay, there.
Okay, answers?
28.
27.7.
Any others?
I got 3.
Goodness.
I got 3.8.
You got what?
3.8.
3.8?
Not bad.
28%. Well, that's 27.7. I just rounded.
Any others?
So do you want 27.7 or can we just round?
No, I want the correct answer.
Okay, in that case, we were settled.
Okay, so let's work it out. First of all, when you're faced with a problem like this, what should you do first? Before you convert. Figure out what we need. Let's write down the formula. This is a mass percent problem, so we have to recall what the mass percent formula is. So mass percent is equal to the mass of the solute over the mass of the solution times 100. So in order to get mass percent, I need to know two things. I need to know the mass of the solute and I need to know the mass of the solution. Do I know either one of those directly in the problem? I know the mass of the solute. So I know that there's 500 grams of sodium hydroxide. So it comes down to knowing what the mass of the solution is. Am I given the mass of the solution in the problem? No, I'm given the volume in the problem. So how do I change a volume into a mass? I use the density formula. And the density formula is what? Density is mass over the volume. Like so. So I have volume, I want mass, so can I solve this mathematical equation for mass?
Yes.
What would you suggest I do? Multiply both sides by V. So I get VD, never a good thing, is equal to the mass, or the volume times the density is equal to the mass. So what is my volume?
1 liter.
1 liter. What is my density? Is that given in the problem? It's 1.3 gram per milliliter. Okay, can I multiply those two and get the mass?
No.
There's a problem here, right? And I've caught that problem because I was diligent enough to use all of my units. And when I do that, I say, hey, wait a minute, these are not going to cancel. I need to make a conversion. So probably the easiest thing to do is to convert the 1 liter into milliliters. Can I do that off the top of my head? I'm supposed to know that definition. There's 1,000 milliliters in a liter. So now when I multiply that by 1.3 grams per milliliter, the milliliters cancel and I'm left with grams of solution. So I end up with 1,300 grams of my solution. So I can put that directly in the problem here, multiply by 100, and if I do that math correctly, I get the 38.5. So 28, how did we get 28?
You get the what?
Adding
I-
500.
You added it in. Okay, remember, key word, solution. Here.
You said dissolve 500 grams in here, so you can have 500.
You're right, it's worded poorly. It should say is dissolved.
It does
Yeah,
say that you dissolve another 500 grams into the towel.
it does. It's a cheap shot.
So. You can make sure there's no mistakes like that on the test, right?
I will. I'll
Okay.
double check the wording.
Alright,
And if you're confused during a test, what can you do?
get up and ask, that'll take too much time.
Exactly. All right. Good point. Worded poorly. All right, we'll watch that in the future. Other questions on this problem? Yes.
So we don't add the values to the 13.
I would not. Not if we're dealing with a total amount of solution here, then we already have solution. We don't have to worry about the,
Oh, solution.
Yeah. Now, we also remember that I don't have to ask for mass percent. If I have a mathematical formula that's got essentially 3 variables in it, I don't always have to ask for this. I can ask for one of the others. Same with the density. We have density is equal to mass over volume. And so, do we always have to ask for density? No, we could ask for any one of the 3 variables. So here's a problem.
Did you wish for one?
So we have a solution that is 8.4% sucrose or sugar in water. We have 91 grams of the solution. How many grams of sugar do we have? Go. 12 more seconds. Answers?
Hang on.
7.64? Yes. Want to make sure there's no other answer.
7.6.
I don't wanna write it down.
Okay.
That's what I got.
Let's work it out. Well, again, mass percent is the key. The tell us, oh, mass percent formula. So I can simply write down that the mass percent is equal to the mass of the solute over the total mass of the solution times 100. And then I go through my problem and try to pick out the pieces that I have. I have 8.4%. What do you think that is? That's my mass percent. So I have 8.4 is equal to, now, do I have the mass of the solute?
No.
No, that's actually what I'm
you're
looking for. That's my X value. And do I have the total mass of the solution?
Yes.
91 grams times 100. So can I solve that for X?
Mhm.
And I think you get 7.6 when you do so. Tell me what you did.
Multiply 91 and 8.4 and divide that by 100.
Let's finish it. It's the same thing, so you cross multiply 8.5.
So look at what we would do here to solve for X. You would multiply both sides by 91. So you would have 91 times 8.4, and then you divide both sides by 100. So you actually did the same thing we did. Okay. Any others? Now, there are other concentration units that deal with percentages. There is, for example, a percent by volume. What would the difference be? Instead of using mass, we're using volumes. We would have milliliters over milliliters. There is actually one that's called a percent by mass volume, where they take the mass of the solute and the volume of the solution. That is not a common thing to do. Nurses do it. And so it's found in certain career areas. For our purposes, chemists pretty much deal with mass percent. And so the only one you'll be required to know for the exam is the mass percent. None of the other percentages that you find in your book are going to be on the test.
So we don't have to do the mass volume.
Nope. You don't have to do volume percent, you don't have to do mass volume percent, you just have to do mass percent.
So if they only go practice, then
I'm sorry?
if some of those problems are in the practice exam.
Then you need to let me know immediately because I never put them on there. I've only put mass percent on there. So someone's been messing with the practice exams. We need to find out why. So you find them and let me know. Okay? There is one other concentration unit that we do need to know, and to the chemist, it's probably the most important concentration unit there is. Now, you've had almost a full semester of chemistry. Proud of you. Suppose you're at a party over Christmas time and somebody comes up to you and says, what did you take this semester? And you said chemistry. And they said, oh, what's the single most important concept in chemistry? Without hesitation, what would you say?
Like Dr. Braun.
Concept, not God.
Conversions.
You'd say what?
Convert everything to
Math?
Conversion.
It's moles. It's moles. The single most important concept we have is moles. Think about it. Everything is done in terms of moles. Chemical reactions, stoichiometry. And so, would it make sense for us to have a concentration unit that related directly to moles? Yes, we would. So, we have one, and it's called molarity. Now, molarity is symbolized by a capital M. Important, because a little m means something different. We're not going to learn what the little m means, but to a chemist, a little m is different than a capital M in terms of concentration units. So you want to make sure that you're using a capital M. And it's defined as the moles of solute divided by the volume of solution, and that has to be expressed in terms of liters. So you see the units for molarity are moles per liter. So, suppose the problem says to us we have 3.65 grams of HCl in 500 milliliters of solution, and we want to know the molarity. Again, read the problem, and the first thing you should figure out when you read a problem is, what am I being asked for? Once you've identified what you're being asked for, then you should be able to identify what relationship exists for you to get that. In this case, we're being asked for molarity. Surprise, surprise, the equation should be the molarity equation. So the thing that you should come up with right away, at least on your scratch paper, is molarity is equal to the moles over the volume. Now I search my problem and say, do I have any of those given directly in the problem? Do I have moles given directly in the problem? No, I don't. But what am I given? A gram value. And can I convert grams to moles? Golden rule on our arm, tattooed, right? So I have 3.65 grams of HCl. How would I change that into moles? I would need the molecular weight. So do I go to the periodic table?
Yeah.
No.
That's up there, 36.5.
It's giving it to you in the problem. Don't waste time. 1 mole is 36.5 grams. So I have 1/10 of a mole of HCl. How about the volume? Is that given to me directly in the problem?
No.
Right, it's given to me, but not in the unit I need, because the volume has to be expressed in liters. So 500 milliliters, can I change that into liters? Yes, because I know 3 Greek prefixes, centi, milli, and kilo. So I know that in 1 liter there are 1,000 milliliters, or I'm dealing with 0.5 liters. Voila. Molarity. I'm sorry? You can put either. If you put the capital M, that stands for moles per liter. If you put moles per liter, it's clear. So either one would be fine. All right, here's our new problem. You have 5.0 molar potassium hydroxide. The molecular mass of potassium hydroxide is given as 56. How many grams of potassium hydroxide are in 300 milliliters of the solution? Go. 12 seconds.
Like 300.
300 milliliters. Make a better door than a window. Gonna bet your life on it? Gonna bet your life on it?
No, I don't gamble. It's illegal.
It's probably wise. Because
No,
So what did you actually calculate?
it's no.
Uh,
Dr. Ron,
That's molarity, capital F.
you can do it. Dr. Ron, since I have 300 milliliters, do I have to convert that to liters?
Does your formula require it to be in liters?
Yes.
Then you have to do the conversion.
And then solve for X.
Sounds right. Part of it.
Okay, now it's good.
What's the answer?
This is how far I've gotten. For this to cancel.
Okay, good, excellent. Changing the liters, what did you have to divide by 1,000? 84 grams.
So 1,084 milliliters equals 1 liter.
You gotta change, I got you.
Alright, so
So you have to divide by 1,000. So that'll be your liter. Divided by 1,000. That's your liter.
never mind.
Okay, now you're telling me.
Never
Correct, so.
0.0.
Multiply the 0.2.
Thank you. I'm good with
That's the moles of what? What did you just say?
grams.
No, that's your moles. So now you gotta transfer.
Now I gotta put percentage. Okay.
See, so how you gonna change moles into grams? By what?
I thought right here I was converting my milliliters to liters,
Which is correct.
and then how many grams? Okay.
So you're looking for grams. So you got moles. Okay. Like that. So he's giving us the left.
Now I gotta convert it.
Okay, so, our answer is 84 grams?
Yeah.
We all get it?
Yeah.
Okay.
No, she didn't do it.
So it's a molarity problem, and I have a molarity formula. So I'm gonna plug in some numbers. I know that the molarity is 5.0. I don't know what the moles of my KOH are, but I do know the volume of my solution. However, the volume of the solution is given in milliliters, and I need liters. Can we do that in our heads? All right. So the XKOH would be equal to 1.5, and remember that's moles from our formula. That's moles. Can I change moles to grams? Yes. I would multiply by the molecular mass, which is 56 grams per 1 mole, and I think that gives you 84 grams of the KOH. Okay? Piece of cake?
piece of candy. Better than a chocolate food.
It's just a fun. Oh Lord, we're gonna Google this shit.
Goggle.
Go.
Is that 6.0?
6.0.
That's 6.0?
Our lab HCl is 6.0 molar HCl. For reaction, I need 0.16 moles of HCl. How much should I measure out?
And you say if half of my moles, the molarity equals half the liters, and then you have your molarity and you have your moles and liters, so you just say that that's the mass problem. And then you just go 10,000. It's a lot. No, it's 10,000. 20.
Oh.
10,000.
I've never heard of that either.
Please excuse my dear Aunt Sarah.
Yeah,
Tyler.
Or Sally.
Sally.
Yeah.
Oh,
There was something I was saying to you, so I forgot that one. 10 dies.
Oh, yeah.
Yeah. I'm just waiting.
Where'd you get it? But she got 0.03.
Yeah.
Yeah. You don't need any biology like now either. It's like I know how to do it when I start school, but I don't ever know how to just set it up.
Yeah.
So that's why I'm doing
I'm over here.
You know what you're doing.
I mean, without knowledge.
So you're looking at the leader. It's giving you the molarity and it's giving you
What's that?
okay. Oh, 6.0 equals something. Thank you.
You're just rearranging it. He's giving you the molarity, which is the 6. And he's giving you the moles of the solute. So you're looking yeah, rearrange it.
You start with the
Yeah. So what would leaders equal?
Don't know the formula.
No, we need to rearrange this.
That's basically asking you how many liters and like I can do. She should round it. I did, I rounded. The way he's working. I'm bad at that.
No.
Did I make up some rules?
Leader. You're close. You did your leader. You know, leader. The real
What did you do? What did you do?
0.026, but she rounded it to 0.0.
That's correct.
Leaders equal. No,
Strictly not.
that would be the formula.
Where'd you get that from? Previous knowledge?
Because if you're rearranging. Moles equal.
11. I think it's 11.
Right here.
Next month is in 12:31.
Moles over volume, right?
Mm-hmm.
So you're in college algebra. Molarity, is that what molarity? Yeah.
It's a complex
Anytime. Volume, which is liters. We're just gonna make this liters, because that's what we're looking for. Volume is the same thing as liters. So if you do liters on the side, it's like, so we know that liters, which is volume,
I knew it.
times the M equals mole. You're not looking for moles.
Oh, I
You're
should have
looking
done
for-
this.
Yeah.
I should multiply it by L.
Well,
Because it could be grams, but I mean, like, I was wondering.
if it's gonna be grams of a solution, all right, in this case, you know it's a molarity. So you set up the molarity formula, what's the missing parameter? It's the missing is the volume. So if you want grams, then you're gonna need to know what? The density. That's not given in the problem, so you're probably just settling for the volume.
Okay, Tia. I get what you was trying to tell me. Thank you. So you got 0.05, I mean 03. Right?
So our math comes down to 6.0 is equal to 0.16 over x. How would you solve this?
6x equals 0.16.
Okay, multiply both sides by x,
Divide by 6.
then divide both sides by
0.03.
6. We'll get that x is equal to, like so. Okay? Questions?
I was making it complicated. What's the hour lab?
I'm not gonna make them any harder.
What time are you taking your math? You can't make them any harder.
I think I'm taking mine. I know mine's Tuesday, so
You can't like, be like, but I mean, I'll pick that, but I'm waiting for the.
I got the 15. I got the 15.
I'm not mad at it. But I'm gonna wait. I signed up for that class, but I'm gonna wait.
Now I know who I'm
going to.
Next semester, I have this Tuesday.
I don't know who I don't have. I didn't sign up for him. I'm thinking about. Sign up for addition.
What is it? History, statistics, chem labs, theater. I'm missing one. I know. I'm missing one. Yeah, so I'm missing psychology.
I am. Trying to come up with new experiences for you.
47 grams of salt is thrown into 100 milliliters. So we're making salt water.
Yeah, we're making seawater.
Wow.
I'm sorry. Next class, you want to upgrade, pay a little more, get a better seat.
Yeah, I think so, yeah.
Okay. Step by step in this one, Lord have mercy.
Too small?
Can you read that?
I can. 47 grams of salt, sodium chloride, molecular mass is 58.5, is thrown into 100 milliliters of water, dissolved, and more water is added to 2.5 liters of solution. What is the molarity?
Is the solution salt water?
Pretty much. What else would it be?
Well, I don't know, I'm just trying, it's just worded. I'm not really. More water is as much as 2.5 liters. That's not very. Ultimately, 2.5 liters. To become 2.5 liters.
Liters, and then 2.5 liters, so it's 2.6 liters. Okay, divided by 2.
So the ending volume is
Because touching somebody else without permission. Some people freak out because they have brand new shoes. I don't do it because I'm touching it. Like, I was just a bumper, I'd still say sorry. Not because it hurt her, because I touched her. Yeah, I appreciate it.
Then sell your expensive shoes. Can't even afford a toothbrush that you have that.
What'd you get? Sydney.
0.308.
Sydney is her name.
0.3.
0.308. They call me something different.
Where? I'd love to see you in the club.
In the club.
I would love to see you in the club.
Oh my goodness, look at me.
Crown and that. I watch that shit all day long. What are you getting? Huh? Nothing.
You got as much as I got?
I didn't get her concentrate. I didn't get her. I got 0.3. That don't make you bright, yeah. You're about to know though. Yeah.
That's what I see.
15 minutes.
Okay.
15 minutes.
15 minutes.
What'd you get?
0.32 molarity. Yeah.
Negative. That's not what I got.
Your first step is to convert this gram into moles. You're looking for moles of NaCl.
How come you gave it to him?
No, they give you the molecular mass to find the moles. You have to do the 47 grams.
Is this right? Does this ever come into play?
No.
133.
Oh God.
Okay, so it looks like the answer is 0.32.
This is so wrong.
Trouble?
Yes, Dr. Brown, can you start from start to finish?
Sure.
Thank you.
Molarity is equal to moles per volume.
Per volume.
So, do I know the moles of my solute? Can I get the moles of my solute?
Yeah. Uh-huh.
And we get a value here of okay. So back to my formula. I now know the moles. And after I add the more water, I'm going to end up with 2.5 liters of solution. And so my sources tell me that that's
Oh, to become 2.5.
this. Yes.
I added the 100 milliliters of extra water, which is really 2.1.
Yeah, before you wrote become.
The original 2.5.
Well, what it should mean, I added this word.
Okay.
It should mean if added more water is added to, that's the common terminology that we use, and I understand that can be confusing, so somebody pointed it out and I went back and put in the word become. So it's the final value of 2.5. So you added 100 milliliters onto that? Shouldn't have been much different.
No, it was 0.1 difference.
Yeah, so.
So basically, the these and those correct.
That's one of them. All right. I'm sure there are more of these in the book and online and on the practice exam. So let's try one more idea.
Can I ask a question?
You have a question?
Yeah, one of your questions said that if a solution is diluted, does solute remain the same as it become less or it becomes
Well, let me see if this answers it, okay?
okay?
Suppose I have a beaker of some solution. Let's say it's HCl, some nice acid. And I'm going to give you certain information about this solution. I'm going to tell you what its molarity is. Its molarity is M1. Okay? I'm going to tell you what its volume is. Its volume is V1. If I gave you those two numbers, M1 and V1, and asked you, could you tell me the number of moles of HCl that I would have? How would you do it? Good. So the moles of acid would be equal to M1 times V1. Molarity times the volume. We can see that right here. We solve for moles. Molarity times the volume should equal the moles. All right, great. Now I'm going to toss that into a larger beaker. I'm going to add a bunch of distilled water to it. Has my volume changed? I'm going to give you the new volume, V2. Has my concentration changed? I give you the new concentration, M2. If I were to ask you to calculate the moles of acid in the large beaker, could you do it? What would it be?
V2 times M2.
So the moles of acid would be M2 times V2. So, what that's telling me is, let me ask you this. In going from the little beaker to the big beaker, did I add any HCl?
No.
Did I lose any HCl?
No.
So what has to be true about the moles of acid in the small beaker and the moles of acid in the large beaker? They have to be the same. And so, we have just derived a dilution formula. A dilution formula tells me that if I have a certain amount of stuff, can I add water to it and make it a different concentration? And that's exactly what we're doing. So, suppose for lab, Molarity. It stands for the molarity in the first case, first condition, small beaker. M2 is the molarity in the large beaker, because we said they changed. So, I'm given a problem like this. For the lab, I need 2 liters of 3 molar HCl, but we have 12 molar HCl. Now, what you have to do when you're faced with a problem like this is ask yourself the question, what's happening here? How am I going to go from 12 molar to 3 molar?
Add
I'm going to add
Water.
water,
solution.
and that's a dilution. So immediately the dilution formula comes to mind. And the dilution formula is M1V1 is equal to M2V2. What I would do then is over on the side of the paper, I'd make a table. M1, V1, M2, V2. And I would go through my problem and pick out the data. For lab, I need 2 liters. Okay, 2 liters. Is that a volume or is that a concentration? It's a volume. V1 or V2? Or does it matter? Doesn't really matter. The first one's a freebie. So let's call that, it's the first volume I came to, I'll call it V1. 2 liters of 3 molar. 3 molar, is that a concentration or a volume?
Concentration.
M1 or M2? Or does it matter?
It does.
It does matter,
You got two.
because that concentration has to be related to my 2 liters, so it has to be M1. So this is 3 molar. But we have 12 molar. Is that a concentration or a volume?
Concentration.
Okay, is it M2 or M2? Must be M2. And so what am I looking for? Should be clear, right? I'm looking for V2, which is the volume of 12 molar. In other words, how much 12 molar should I take to add water to get to this 2 liters of 3 molar? Now, back to the equation. Can I solve this for V2?
Yes.
Yeah. V2 would be equal to M1 V1 over M2. Can I go to my little table on the side or on my scratch paper and plug in those numbers? So this is 3 molar times 2 liters over 12 molar. Look, the molars cancel. Okay, 0.5 liters. And good news, I got liters, and I'm looking for a volume, which is liters. So this is telling me what? Take 0.5 liters of 12 molar HCl and add water to it until I get to a total volume of 2 liters.
It should be 6 divided by 12.
Isn't 6 divided by 12.5?
So then, could you say, okay, how much water do I need, and you say 1.5?
That's a good question. I could. And for practical purposes, it would be true, but it's not really true in theory, because suppose I did this. Can you give me an answer here? Turns out to be about 95 milliliters. And the answer is that these 2 different substances can actually get closer to each other than the individual substances could to one another. I can give you a perfect example. Take a beaker and fill it with marbles. Fill it until it's right up to the brim with marbles. Can I fit another marble in there? Say no.
No.
No, I can't. But could I put sand in there?
Mm-hmm.
And why would I be able to add sand to a full beaker of marbles? Because there's space between the marbles that the sand could occupy. So, in chemistry, what we find in general is that volumes are not always additive. We can't be certain of that. So what we would do is probably do it like they say, add up to 2 liters in some kind of measuring device so that we aren't adding 1.5 liters necessarily, although in the case of water, I think it would be pretty close.
So that wouldn't be like.
It could be. The whole thing could be a question now, right?
Why wouldn't I add 1.5 liters of water? Yes, ma'am.
This may be what you're just talking about, but I'm so confused. The 0.5 liters, what is that answer?
That answer is V2, and V2 is associated with M2. So that's telling me, take the stock solution, take the 12 molar HCl, and measure out a half a liter. Okay? Put it in a vessel, and now add water to that until I get to a total volume of 2 liters. And then I should have my 3 molar HCl. That's actually how we make it up in the laboratory. We only buy 12 molar. 12 molar HCl is the saturated solution. You can't get any more concentrated than that. And that's all we buy because we don't want to pay freight on water when we have a still and can make our own distilled water. So we dilute all the solutions from 12 molar to what we need in the lab. All right,